time to wake up. It's time to wake up. It's time to wake up. It's time to wake up.
Before we get into the questions in general, I will start off by getting my guests the panelists to introduce themselves. What do they do and their background? So I will start off with Rami.
Hey everyone, firstly, thank you very much for joining us here. I'm currently the head of business development and partnerships at a quantum computing company called Terra Quantum. Just, who is head of quantum computing in the crowd before I even... Okay, good to get my audience so I know how deep we go into the topic. But in addition to my work at Terra Quantum, I'm also a mentor with the Unreasonable Group as an accelerator specifically focused on scaling climate tech and sustainability-related companies. And I'm also a former founder of my own business, which was a community bringing leaders in this impact space together. So really excited to be here, and thanks for having us here, Bernard.
So before that, is quantum computing another 1,000x after AI?
Did you say 10,000?
Yeah, 100,000.
Yeah, there we go. Now we're talking. That's what I like to hear.
Okay, Aaron?
Hi, so thank you for coming. I am Aaron and I work for the Lufthansa Group. I am a consultant with Lufthansa Systems and I'm sent to do different types of projects around the group. One of the big projects that I've done recently is to look into how we're making the entire IT profile of our company greener. We have not looked at this in the past, and so this was the first time doing this. So this is a little bit of what I'm going to bring in today, as well as having the project just prior to that of implementing open AI technologies all across of our group companies and the governance around and what does it mean for a large corporate. And then before that, the implementation and scouting of all kinds of different technologies over AI, over lightweighting, over e-fuels, which is the kind of real reason for this whole festival, to look for clean tech possibilities to bring into the company in order to make our whole profile as a company lighter. So I'm trying to bring in AI from the perspective of the advantages that it provides for a large corporate, the disadvantages. There's a little bit of double-edged sword here, and I will get into that a little bit.
Ingo, how about you?
Yeah, hi everybody. I'm Ingo with Huawei. This is my 4th GreenTech Festival, and it's great to be here again. 4 years ago, I had the honor to give a keynote about 5G, and I had to explain why 5G from the telecommunications sector has an impact on sustainability and the whole society. I'm still dealing with this stuff. Yeah? So telco, Huawei is very big in hardware infrastructure that you need to run networks, but also in the IT and computing domain. And this is what we're gonna explore, I think, a little bit later. Not only 5G, but what is, for example, the potential or the threat of AI to the energy consumption. But we are also doing a lot in PV. This is why Huawei has in the other hall a big booth where we present our latest solutions for PV, in particular for energy storage, as a very important topic to tackle the climate change. And this is why I'm here.
So my first question is, why should we forget killer robots? Oh, sorry, wrong question. The first question is, how is your company currently working to, say, reduce the environmental impact of AI and using different emerging technologies, such as quantum computing, green computing, like sustainable supply chains? Maybe I can start off with Aaron first.
So our company is really, on the one hand, prioritizing the implementation of all of this new fancy Gen AI, because we stand to create a lot of new technology that we need. So we have a hard to decarbonize industry, and the AI, the machine learning and the algorithms that we've been using in the past, on the one hand, will really reduce our fuel burn, which is really the biggest problem we have. But on the other hand, we have Gen AI coming in, which a lot of people are playing with, and which is causing a lot of compute with a lot of energy in the background. So it's about, maybe if you guys are Scope 1, Scope 3 aficionados, it's about we are reducing our Scope 1 at the expense of our Scope 3. What are we doing? We are on our general compute starting to look at what are the different things that we need to have on our radar, because as computing increases all over our whole company, the more innovation we have, the more optimization we do, the more the Scope 3 compute bill kind of goes up. But if we don't do that, then we have the lack of innovation and the lack of basically positive momentum on the biggest problem that we have, which is burning a lot of fuel. So we're looking at what we can do on the digital space right now to prepare for all of the new technology that we will create.
Then Engelbert, what about you? In the data center is actually where most of these compute and the AI energy is being used.
Yeah, Huawei has quite a wide portfolio, and we did a lot of thinking on how we could contribute to more sustainability. And it's our core belief that it's our products with which we are helping our customers. This is why we set our strategy called More Bits, Less Watts. And we made a commitment and said by 25, all of our products will be at 270% more energy efficient than compared to it was in 2019, to all products. And this is how we really try to create an impact. And we are doing this by a lot of, say, small steps, which are also situated pretty much in the domain of engineering and innovation. For example, how to make a base station for the mobile networks more energy efficient, how to better set up and run a data center and stuff like this. And we are taking this holistic approach to make the hardware itself a much more energy efficient, but more importantly, to really create an outcome and consequence for the customers.
Romy?
Yeah, I think before I get into what we do in the quantum computing, to just give an understanding of what quantum computing is for the audience, quantum computing for many people is this faraway concept where these crazy machines are going to become these even more crazy killer robots. But I think in essence, what we really got to think about is quantum physics offers us exponentially more opportunity to capture and actually compute information that we have. So what our vision here is to think about it in a simple way is you can do way more with considerably less. And that very core thinking is exactly what sustainability is about. How do we increase the efficiency? Now, we have to pick the right use cases for this, and we're currently at the beginning of this journey. So what our job as Terra Quantum is to do is, at least on the software side, is to look at some of the most complex problems. And Ingo said a really good one about base station energy optimization. We could look at that, and with our quantum machine learning, we can actually have greater prediction accuracy, which can increase the amount of energy we save there. So what we're doing is we can accelerate those reductions in efficiencies. In another context, we could look at the actual amount of data. In the LLMs, we're using so much data, and what we're trying to do now is not just look at the hardware stacks to see how can we make these more efficient, actually use less data, but on a software side, Terra Quantum with the quantum machine learning can actually compute the same accuracy with less data points. This, again, is already this great path to efficiency. The last one I'll kind of give you guys in terms of another aspect is simulation. A lot of the world that we are trying to understand is beyond our current comprehension. If we can simulate complex systems, molecules, the body, very important parts of the environment better, we can actually understand how to operate in them more efficiently. And what we're able to do is actually simulate these systems with considerably less compute again. So we are basically an engine to help reduce that energy usage across the system, but also try and tackle those problems in conjunction with partners like Lufthansa and Huawei, because we are only one part of the system.
So one interesting thing, just to set the context for the audience here, right? When you go to ChatGPT today, you type in your query, it's actually a 0.02 cents cost per query. So if you pay for the 20 USD, you actually need to make about 400 queries to make your money's worth, right? And then, but if you look at just a database query, it's actually 0.601 cent per query. So maybe one thing I would like to ask is, what kind of innovations in the area that actually gives you the optimism about, say, you want to improve sustainability over time? Could be hybrid computing, could be maybe chip efficiency, or maybe even use cases on that. Maybe Romy, just now you talk about some of the use cases. Where is that drive for you, such that what are the technologies that can actually help you to make that improvements in the lead?
Yes, I think if we look at quantum software as, again, one of the ways of using quantum technology, one lens is how do we actually reduce the energy consumption? And that's what we talked about with the base station. By predicting or improving and the network, reducing congestion, reducing data, compressing these models, we can actually reduce the amount of energy.
Right.
The other way to look at it is how do we actually look at the full value chain? And for example, in solar panels, or if we're looking at wind energy, the biggest challenge we have there is the prediction accuracy of these outputs. If we can predict that again more accurately, we can understand what's going to the grid better, and we can avoid having to turn on other non-renewable forms of energy. I think then on the kind of other end of the spectrum, optimization. So one of the things we look at as well is if you look at supply chains, how can we reduce the empty miles that cars are traveling, aeroplanes are using, or even the ships are on the seas? This is another important way to say, look, we can optimize your route better, reduce empty miles, but the best part is it's a cost saving as well for the company. So everything we think about is business improvement is also a sustainability impact, and that's all software related. On the hardware side of things, I want to put a caveat because in the future, yes, quantum computers could be more efficient, but there are other elements we have to factor in. For example, some types of quantum computers, if you Google quantum computer, you'll see this huge, big gold machine. That big gold thing is not. That's not the computer. That's the cooling mechanism. So that's what we have to factor in. So there's a big cooling that's needed. So our innovation here is to move the temperature up to more normal room temperatures. But once we get there, with these machines, we'll be able to do so much more than what our GPUs and CPUs can do today. So there's a lot of exciting progress. But these problems are very large, they're very complex, and they're very specific. And we always have to also put that context in because you won't use quantum computing for everything.
And
So let's skip over quantum and let's skip over designer computers and bots taking over the world. And have you guys heard about the research coming out of Australia where this startup has not only written code, binary code into DNA, but they've actually now produced a silicon plate where they're having neurons, which have been taken out of a body, an animal body, and getting them to fire when there's no sound and to not fire when there's sound. And they are now doing other things. So I'm also looking beyond, just as an impulse, because there's a few of you on your phones to think this discussion could even get more wild, more insane, and to think beyond compute, and to think that we could actually wipe a hard drive onto our skin in the future and to have it run programs this way. What do you think? You're a hardware guy.
I was just about to get to him about that, right? Because we before this panel, we were talking about materials.
I hijacked it for a little bit.
So what she's talking about is like things like DNA. There's also DNA computing, protein folding. Even protein folding itself is a form of compute. But maybe coming back to the data center part, I think one conversation we had earlier on was talking about something as basic as concrete materials. Maybe, Ingobert, you want to talk more about like just the whole share of improvement of materials. Does it give you any optimism at all?
I would say it's a combination of measures. So on the one hand side, we need all, say, the fancy technologies, where, of course, AI is one of the major ones, but also the stuff you mentioned. But all of this just works on the foundation of a very powerful and flexible digital infrastructure. And this will always remain physical. Even if you have more mobile networks and greater mobile standards, at the end of the day, all the data need to go in a physical infrastructure. And a physical infrastructure will cause a CO2 footprint. This is unavoidable. And we have the big discussion, the more we use these infrastructures, the bigger the footprint is and the worse the overall effect is. So what can we do about it? It's the great, say, the rocket technologies, but it's also, say, the basic engineering. And there we're coming back to our example, or say, the data center. The data center, and we have a huge political discussion, is responsible for a lot of emissions. On the other side, it is the prerequisite to run huge amounts of data that we need for all the digitalized processes in order to bring our sustainability up. So it's unavoidable. So what can we do with a data center? For example, most of the data centers at the moment are constructed with concrete. You could replace it by steel and say steel, which you can use in a recyclable circle. So you reuse it again. You can put it up in modules, not in individual steps, and these modules are pretty efficient. Then we had the topic of cooling. At the moment in Germany, we basically apply air cooling. You could go to liquid cooling, which is much better and efficient. And also the cooling, there's more stuff. For example, what we do from Huawei, at the moment, the cooling in a data center is you cool the entire room. However, what we did is we changed it and put the cooling system just on the blades, what we call a blade cooling. We do not cool the whole room. By this, we also increase the energy efficiency. And it's a bundle of measures, pretty not so fancy stuff, but in a sum, they have an effect. And then you apply at the same time new technology like AI, which you not only use by running and maintaining the data centers for all the predictions and what you said. You already use it, and I think you slightly mentioned it also when you set up the sites, when you do the planning, when you search for the right site, or where is maybe the renewable energy available in order to connect the data center. And there is much more. And by all of these steps together, you have an impact.
Yeah, and just to help everybody, the baseline, I think construction contributes about 25%. If we want to get to net zero, construction is at least 25% on that. But I want to have a much more specific question to Aaron, because we talk about like how does things like ESG considerations that help you to think about things like corporate decision making around things like procurement, your scope 1 investment, and even product service development on there.
Yeah, good question. So in Europe, we have the new mandates from the government which have come in. We have to trace our scope 3. This has come down. It's a top-down mandatory thing that all of the companies have to go through. It's a little bit painful in a large company, and I'll tell you a little bit in detail how it's painful. Or what do they say in Germany? Where does the shoe pinch? Where exactly? So we've just gone through this with the IT procurement, and we have said, okay, now there's a mandate. We will need to put in a certain component in every RFI and RFP in the future, where there's a question list which is based on ESG principles. It's in line with all of the governmental regulations, and companies will have to adhere to this. And there's a percentage which has been set now at 5%, and this is then going into the calculation of whether this is a reputable supplier, what the price looks like, and all of this kind of things. 5% is the initial number that we had thought with procurement was the right number to start with, and our CIO just looked at it and said, 5%, I think this is too low. I don't have the now real figure of what percentage it's going to be, but this was the first example that I can say of when a decision comes in and says, no, we want to do better, we want to lead a little bit here. And what we know is that we are relying on large guys like you for the most part. We're relying on Microsoft and Google and AWS and Huawei and all of these companies. A lot of it is part of the hardware around IT, which is being created, but also the logistics around IT, around sending all of these laptops every 2 or 3 or whenever there's a change of laptops, sending them to all of our outstations for the station managers, and whether this is done via something called co-mail. It's coming to our headquarter in Germany. Somebody is implementing updating technology and getting the computer ready, and then it's going to have another supply chain getting it off. So we were thinking, like, is that the right way to do it, or can we say this is the model that you can have, this is the technology pack, and then when we put it on Azure, then Microsoft can distribute it, and then we can have people just buy laptops locally, register the serial numbers which belong to our company, and then distribute that. So we try to look at the different places where the shoe is hurting in a procurement perspective. And then we have I think 70,000 procurement contracts in a company of 120,000 employees, 70,000 procurement contracts for all of the different things that one could imagine in an airline and its subsidiaries. And this is, quite frankly, too much work for a manual process to go in and see which of these contracts is coming due, which one has ESG components in it, which one doesn't, how mature are they, what is going on. We have no idea. So here we're using LLMs for this kind of very unstructured paper PDF data to go through and to find all of this stuff and to see how we can rewrite or re-request and then make the new RFIs, and when do they need to come out and when do they need to get posted and all of this kind of stuff to just kind of put it in. We did, it sounds like a long story, and it kind of is. It's kind of like a messy, go and investigate different things in the company and see what this whole process of mess looks like in real life. So this is what I was just doing 1 or 2 months ago. But actually, now that we understand how to use LLMs to extract and how to find loopholes or quick ways to do this in a smarter way and not a manual way, then it's becoming a blueprint for the rest of the procurement, categories, if you will, in a large company, that they can then blueprint this and do it all over the rest of the company. So hardware, so software already done, hardware, aircrafts, fuel, whatever we have procurement contracts behind it, catering equipment, whatever. So this is now kind of how this works, and IT is maybe an easier one to start with because the products are a little bit more, traceable, and then there's a little bit more.
Does it also getting rid of paper as well in that process of doing things like procurement, because that's where a lot of that, or you're already fully digital all that.
Catherine, you work for Lufthansa. Have you seen paper? Are there any printers that you can? I don't know. We've already done a lot of paper removal. There's no more paper in cockpits, and there's no more, very little. So that's already been done. There used to be, I know, over 100 pages of catering loading equipment, like where's the Diet Coke? It's in the drawer number, blah, blah. It used to be an insane amount of paper, but this has already been digitized 10 years ago.
Okay.
13 years ago, something like that.
I want to hold a thought because we have also agreed to open because we have a very big audience here. So maybe I want to take at least 2-3 questions because I don't want to, we just talk here and talk. Anyone have any questions? And then, yeah. Yep, go ahead. Can we bring a mic to the lady there? And I will repeat the question from there. Yep. There.
In the back.
Yep.
Thank you very much. My name is Larissa Köster. I'm working for industry with producing thin film technology. So we are very energy intensive and use a lot of heat energy or process energy. And as we are a chemical industry, we have a lot of chemicals we buy and we procure and we then work on. And our problem is, we want to use software. We're looking at something for doing our scope 3 emissions and everything. But my question is always, software can help, but where do we get the data, and how do we know that the data the AI, for example, takes for PET layers or something is accurate, and where is it? Can we get the sources, and can we then know? Because we know that in the past it happened, and everyone was relying on something, and then it came out years after that there was a misfold or a miscalculation, and everyone believed this, but it wasn't true. So I'm afraid that AI can help here, but people are relying on this information and they don't trace it back. They say, now we have a tool for scope 3 emission, and they don't trace it back and they don't have the sources. So how do we deal with this?
Engelbert.
Yeah, I think it's a very fair and good question. And I would have raised it at the end when we maybe talk about political or regulatory measures. So if you want to really use AI for such processes as you describe it, of course, data is a prerequisite, as you said. But not any data, a good data, a validated data, a trustworthy data. So that means we need standards for data. We need data platforms. We need data spaces. So you're probably aware there are projects by the political sector, such as called, or in cooperation, the political, but also the private sector, like Catena X. Yeah, it's about huge industry data spaces where they exactly deal with this kind of questions, where you bring the data even across continents together in one protected space, yeah, and where the companies can rely on and use it. Yeah? So my question would be, it's a long journey, but you need something like a space, a standard to which everybody applies. And that should be the solution, because as long as everybody does it for himself and just control it on its own side, it won't work. Because we were talking about the supply chains, the complex supply chains, and everybody has that. So you cannot regard this as separated. So, and therefore, I would pledge for this data spaces with the standards, and which is a lot of work, but probably worth to do. And then every company can use it. And if you look at technology, it's the technology, but at the end of the day, it is to make it scalable. Yeah? And you just make technology scalable by standards, yeah? That everybody knows what to do in order to get a specific result. And this would be exactly my answer to your question.
But I think also on top of that, we sit on the other side of the equation because we are the solver. We're going to come to you and say, hey, look, we're going to make your life better. We're going to reduce your heat loss. We're going to improve your efficiency. And then you've got to verify that, are we using the right data? But we've learned the software companies are much more advanced now. They understand this is a massive problem, because if they get that wrong, it's their own reputation at risk. The other thing I want to bring to the point here is that there's a lot of open sources of data now and a lot of benchmarks to start with. And I think if you only wait for the data to be ready, it's that chicken and egg problem, and eventually you're going to fall way behind the curve. And that's when you start making the rushed assessments and maybe make those mistakes. So what I would always say is that in some of these cases, you can already start with the proof of concept with some sort of smaller data set to at least start the process to understand your systems, because that's the first step. Then there's integration, there's the architecture to consider. And we've learned all these things. So we always encourage clients, if you have a problem, let's start looking at it now. But then in that journey, we also help you find what is the right data and then look at the right benchmark. So it is a bit of a journey, and I understand the challenge. But I feel that with companies like Snowflake, for example, who are coming through, they are trying to help in terms of making this data more accessible and actually provide it in a better way. And open source has also changed that. So I do think we're in a different place, but the journey is still quite a long one.
And if I can add, I think that there's a lot of potential coming in the next kind of 12 to 24 months with regards to the fancy stuff, the opportunities coming in where LLMs can help to clean data. The labeling and the standardization of data is important, but once you have those elements, which are the basics, then you can infer data, you can use unstructured data and quickly structure it. And this doesn't have to be done, like I think currently, quite manually. And this is the big burden of data. And in the future, this kind of AI cleaning and preparing of data is going to be much lighter from a human touch perspective, and will accelerate all of the development that we want to do. We have a huge amount of unstructured data coming off of our aircraft, and now we have a new EU data regulation which gives this potentially golden data into the hands of the user, which it didn't used to belong to us. We didn't have access to it before, and we don't even know what is in there. There's like stuff coming off of sensors from our aircraft. There's 1 terabyte per aircraft coming off per flight, basically, and we don't actually properly know what's in there. But we start talking to scientists about this data and say, what could we make with it? What do we think is in there? And then the kind of brainstorming of thinking the potential of it is, if we have different types of data coming off of different sensors and we're able to triangulate this, then we can maybe infer data which is super valuable, which doesn't exist anywhere in the world from one single sensor. And I think this is kind of like where this is going to go. And I think quantum, if I'm not mistaken, is also going to be very strong in this regard, to take small bits of data and to elaborate it, extrapolate it into a very rich, huge data set, which then can allow you to make massive decisions with regards to things like how do you mitigate, I don't know, any of the big climate problems that are being discussed here today. It's that kind of huge data set in a structured, clean way which is needed to solve it.
Absolutely. I mean, yeah, and as Erin just said, we're totally ready to take on that challenge and help Lufthansa with this massive data problem.
Okay, but I just want to dive a little bit deeper, right? Because one of the big change that generative AI brought about is zero shot and one shot in terms of like doing object detection, etc. And there's also the problem of hallucination. When you think about implementing these generative AI, how do you think about controlling hallucination? I mean, I always tell a lot of the CEOs who ask me for advice on AI, I always tell them hallucination is a feature, not a bug, and you need to constrain hallucination.
So when I used to work in airline catering, and we had a autonomous forklift, and he had a sign on his back. Like, I don't know if I grew up in North America. We had sometimes like teachers would walk around with a sign on their back, or kids, which said something not very nice, maybe derogatory. But so we know that this is possible, and we thought, okay, we're replacing somebody's job with a robot. Maybe there might be a little bit of backlash. We called him Luigi because he looked like the little Italian Luigi from Pixar Cars, because it was back when Pixar Cars came out. But we put a sticker on the back of Luigi, and we said, I'm your new colleague. I'm not here to take your job. I'm very nice. Please let me get on with my job, and we can be BFF or whatever. We said something like this. And if you're talking about how to make the technology accessible and whether we have LLMs which are hallucinating, I think you have to give people who are using the LLM the feeling that it is an LLM, it is in its Kinderkrankheitenphase, the teething problems, and that this part of the feature, not part of the bug in a way, or that the bug is part of the charm. But if you're talking about responsible AI, you always have to make sure that the consumer of whatever has been created knows very well that this is a computer which has been trained on this specific data set, and anything which is a bit weird, please forgive. This is, it's his first day or her first day on the job, and they are getting better and smarter all the time.
But I think also, like, that's all about application choice, right? I think we all have the responsibility, and we've got to do that due diligence on what application are we actually going to be using generative AI for. So in those early stages, if you have that clarity, then you can spot these hallucinations, but you can also manage them. And like you said, it's a feature. But I think what happens is if you don't know what you're looking for, that's when the problems come in. And I think, we spend a lot of our time with customers, not just doing the solution, but also explaining why and validating why we chose that application, why that use case makes sense, and what should you be looking for. So I think this is also an important part, is also that use case choice. It takes a lot of time, and you really have to make you have to know what the output could or should look like.
That's a good question from the audience. Let's take one more question. Yep. Yeah, we can make this more interactive. No, yeah. 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 Do you want to take? They can do next. Yeah.
Hey guys, that was very interesting. So the title is actually "Forget Killer Robots." Is AI destroying the planet? And
Forgot about the title.
Yeah. And I think what we're hearing from you guys is how AI is actually good and helping. So my question. So my question is more along the Bernard's initial comment about AI and data centers producing more emissions now than naval shipping combined. So maybe Romy, like, how does, for example, quantum computing impact the utilization of this ever exploding data that we are present in, where Erin mentioned terabytes of data by just one flight? How do we handle all of these data, and do we even need this extent of data to produce good AI, or are there better ways? And then how do we handle the ever-growing data center costs and carbon emissions that are being produced? And do we even need to go down this road? Because there's productivity for productivity's sake at certain points. So, yeah.
Well, I think that's a great question, and for those who don't know, Ayush is my colleague, so he knows he knows the right questions to ask his colleagues on stage. But I think for me, there's two parts here. One is the coupling between hardware and software. So I think what we've got to look at is it's not one or the other, and we have to look at, like with Huawei, for example, what you guys are doing and try to understand and maximize the utility of every machine, but then putting software layers in between to ensure that we can not just have more efficiency, but also increase the output and performance. That's where we come in on our software, and we have to think, okay, what can we do now? And one of the best things is looking at how can we actually compress data sets and still maintain accuracy. This is a big problem because if we look at anything like one big problem that customers face in like the financial industry, for example, is customer profiling. They've got billions of lines of data, but to put that into a machine learning algorithm, it would just completely break down because there's just too many parameters and they're trying to get too much information out of it. If you can compress that, not only are you saving the cost of how much data is being actually processed, that's an energy saving, but that allows you to actually compute and get the output of it because it's a much more manageable data set. So that's one kind of innovation. I think the other thing is then also looking at future compute stacks, and that's what we look at we have a subsidiary company that's looking at hybrid quantum computing cloud. Okay, that's a big mouthful. It's nothing crazy other than the fact that in addition to having now GPUs in the equation, we add quantum computers and simulators. And what this allows us to start doing is seeing, okay, how can I offload a really heavy piece of compute to a quantum machine that's supposed to be able to handle it, but still do something that the CPU does very well, which is for a very specific task. And you can parallelize that stack. This allows us to have a much more efficient compute across the whole spectrum, reduce the energy, but again, get that better output. So it's always about that interconnectedness between software and hardware. But again, also finding the right applications, because for some, unfortunately, you just need big data. But I guess that's the whole journey, right? We're at the beginning of this journey. If we look back in 5 years from today, maybe the models will be way smaller, and we'll have saved Lufthansa's big data problem with TerraQuantum.
Well, I want to point. Sorry, let me just point this out then. But you talk about like the software piece, right? There's also Moore's law that's in play. How would that actually? There's definitely efficiency gains that come from Moore's law that will also reduce the amount of cost of computing as well, right? So,
yeah. So I think it's two directions. And it's more or less building on what I said earlier. So it's on the one hand side, the technologies itself. Yeah, there needs a lot more to be done to make them more efficient. Yeah, with say simple steps, as I mentioned it for the data centers, but your technology, quantum technology, is a completely new way on how to process and handle data, if you want. So yeah, these are new methods. Yeah, this is very important, and I think we're gonna see a lot here. But the other direction is, to put it on a meta level, is what you can gain with all this technology, more digitalization. So my assumption would be, and we could even get here evidence in various studies that we have run, is if the better your level of digitalization, of digitalized processes, yeah, the more is your overall efficiency gains, and the better is your sustainability, if you want so. So, for example, we did a big study with the Wuppertal Institute, where we tried to look ahead and get this a little bit more specific. And if you go in this direction, it's several parts and evolutions, yeah? And the consequence of the end of the day will be that applications will lead to a real transformation. If you take here the mobility sector, yeah, it starts with simple things like an app planning for a journey or something. But if you go further, yeah, if you look, for example, what the topic also which we strived on the circular economy, yeah, for what you need the data and where the various suppliers are interconnected and so on. then you will have huge positive overall effects. But you will just get them if you have a high level of digitalization in terms of the application, but in particular also in terms of the digital infrastructure and the connectivity. Yeah? Or if you take simple examples in Germany like e-government, yeah, this is virtually not existing. Yeah? But imagine a world where this would be the case. If nobody would go to the office anymore, would just do it online, and the positive overall effects you would have. That means the more you do or the more you invest and roll out such technologies, the better also are your overall gains. Where at the same time, of course, you have to make sure to control the carbon footprint of the technologies itself.
I also think that there's a really big, like we're at GreenTech Festival, which is talking about tech, but it's a B2B with a very also B2C audience, and I'm in the midst of both right now. And what I'm feeling is this question that Dale wrote and that you asked again. What is the actual damage that AI is doing? I don't think that it's the technology, it is the way that we're using it. If you're talking about the use of AI in a business context where you're trying to solve climate problems, this is right up the alley of the mission of the GreenTech Festival and all of the people who are here and what we are doing in our everyday jobs. If you are talking about the after-work version of all of us that we want to hide and not talk about, where we're scrolling cat videos, where we're commenting, where we're doing whatever kind of digital disaster mess that we're making, pollution that we're making, this is kind of the equivalent, all of this data, to the throwaway plastic glass, the throwaway plastic straw. And I don't know when all of this data actually needs to be saved. What we're doing in a corporate context is looking at all of these Teams messages. How long do they actually need to be surviving? There's no real data in a lot of them. This is just like what they call verbal diarrhea, but it's a typed version which has a infinite time stamp on it, unless you have a real policy on when to delete what and what needs to actually legally survive forever or what not. And nothing needs to legally survive forever. There's a rule behind it, and if you clean up that aspect of all of the potential data, then I think you have a much cleaner version. And if you all look at your phones and you see how much of your data belongs to WhatsApp in the percentage-wise of your phone, you're going to see that you're all creating a huge mess in there. So you put limits of when it can be stored and when you can delete everything.
I have somebody with a question there. Can someone pass the mic? Yep.
Thank you. Hi.
Sorry, the lady behind. Ladies first, and then your turn. Ken? No. Okay. You just ask the question, and then you ask the question, and now we'll distribute it.
This is just because you're already speaking about it, and I work in data privacy law. I've done it both with Europe and with United States. And what you're saying is exactly on point. I think it's very, very important for companies and for your clients to really talk to the EU authorities and to say, do we really need to keep all this data? How do we make a particular user's nonsense data? And we all have it from WhatsApp and Gmail and everything else that we use, and to be able to fully delete it. I have spent 2 hours trying to do this with my Gmail. I can't get rid of anything before 2020, and this is crazy. And I bring it up because in the last few days I've had meetings with various different colleagues in various different business areas, and everyone's topic is data center and how do we not just create new, but really think through what we actually save and why we actually need these new data centers, not only just to power them with renewable resources, but Deutsche Telekom has a massive problem with this. It's got hundreds of companies now working on how do we make our data centers more efficient, how do we build new ones, and how do we get rid of the data we really don't need anymore. not only of our own operation, but of our users.
Okay.
We did a digital cleanup week at our company, and we called it the Mary Kondo of your. So we put everything into buckets, and we told people how to get rid of all of their proverbial cat videos or whatever the heck they had on there. Yeah.
Okay, sorry.
Hi, I'm Konstantin from Montel, and regarding I think you mentioned it that it depends on the share of renewables in the power, and then with AI in a big data center, do you like have an eye on the carbon intensity of the power you use to train an AI model, for example? So you could do like temporal shifting to tomorrow because it's greener tomorrow. Do you do anything like that?
It depends on what you look at. So we are coming, from infrastructure and from networks, yeah? And I can tell you, AI is already a very substantial part there. And you cannot run today a network anymore without using AI. Yeah? AI is, we had it earlier, you have it in subsystems, but also in the entire systems where you monitor and where you adjust processes. And these things are so complex, and which are, if you would do it manually, would use, I would say, much more energy and also human energy than the machine, if you want so. I mean, what you're relying to, I'm not so sure. I don't know any exact calculations of this, and of course it depends on the data you're using and where the data is coming from and in which quality the data is, a little bit the topic we had earlier. But for the networks, I can say I don't see this. Yeah? The networks are more efficient because they're using AI, and there are a couple of examples.
I think just to add and to address what your question as well, I think we're seeing some examples, like in one context there's a company called IO.net, and what they do is they distribute the loads to different idle GPUs across an open network where you can submit your compute. If we take this thinking, maybe we can start moving to that model where let me move my compute or training to somewhere which is in a greener energy space at a different time. There are guys thinking about this. I know these orchestration layers are coming up, and also what's triggering it. I mean, maybe it's a good thing, but there's a lack of compute available, so people have to look for new opportunities. So they're already innovating to distribute their loads of training anyway. So I think this is going to come, and what we're seeing as well is in a lot of regions you have off-peak and on-peak, and where you have the high demand. So it is going to come in the next evolution of data centers for sure, because simply for the fact there's not enough compute, and the compute is going to be located around those greener energy places.
Erin, anything to add?
So on this, if you're talking about the localization of compute and going and maybe compute finding energy instead of compute building up wherever it is close to the user and then plugging into the grid and sucking energy, I think there's a trend going towards, and you said you're going into PV, and AWS just bought a nuclear power plant, right? That the compute is now bringing the energy to it, or building the energy, or that the compute feels responsibility for the energy up the supply chain that it's consuming. So I think here it's extremely important to understand the dynamic of this, because as this grows, the responsibility on the users of this, which is, I mean, right now is the hyperscalers, will go up the supply chain into the energy. And this coupling is, for me, a big trend. If you're talking about it in terms of where we sit as a corporate buying this, we know that they all have pledged net zero by whatever, 2030 or whatever it is that they are doing. It's important that this is not only through offsetting, but through taking responsibility of their energy grid or wherever they're pulling power from. But I think that there's a lot of opportunity for local grids just around compute, and then figuring out how to get the latency down so that this is a good story for everybody who wants to use it.
Okay, just one thing. So I'm going to take another question, which is the elephant in the room. What do you see regulations and policy, which is governments, in addressing sustainability challenge that comes from the large data centers and computing? I think we had a conversation on that. Yeah,
one thing, and I really touched it earlier, is data regulation is extremely important, and how you deal with data, make data available, create these data spaces, and unify the data that these models can also be used in a positive sense. That would be one thing. The other thing is, if you look at, for example, what's currently implemented in Germany, it's the energy efficiency law for data centers, which is pretty specific in giving quotas for data centers to combine them with the used heat. So I think here in this regard we have to think a little bit bigger. Also to bring the two things together are very important, but I would keep it flexible. I would give like kind of KPIs, goals that needs to be reached, and then give it, a bit of freedom on how to get there. As I said, there are many ways to bring the POE of a data center down. And it could be about what I said, about the materials, the cooling systems, the planning, and so on. And I would look at these factors and make benchmarks there and kind of regulate in this direction. To say from the beginning you have to use, for example, this particular amount of used heat or of another particular renewable energy is complicated, because each geographical sites in Germany, say, has a completely different precondition, also with the weather, with the climate change. As I said, sometimes it makes sense to use water cooling. If you maybe in Scandinavia or so, not so much, because the average temperature is quite low compared to other regions. So, and there you need then adjusted individual concepts and maybe just come from the overall KPI and make this mandatory.
I agree. You have a feedstock approach, and whatever constellation you're working in and whatever geography and whatever, you have to let whoever is investing in there pick the right supply chain to put it together to make money, and to have it be financially sustainable. Otherwise, there's no point in building it.
But I think, and the other thing is taxonomy, and I think what we've got to a point now is the EU is getting really strict on regulation, and countries within the EU are getting stricter than each other. And then but AI and compute and data is a global commodity and actually a globally used. So I think that's something we're not actually finding any alignment on. Organizations like ITU, for example, try to bring countries together to have these global standards, but there's also protectionism and geopolitics involved about who gets what, who is allowed to use these chips, or who gets to use these solutions. And then we've talked a lot about energy today, but ruining the planet is also ethics, social, it's also other aspects. And I think one thing that we're seeing now in EU is the EU AI Act, and this is all about the ethics behind AI. How do we use it for, in quantum computing, for example, the regulators want to understand what's happening behind these models, which is super complex, and we have a situation where the regulator's always going to be not just one stage, but in quantum, an exponential leap behind. So that's going to inhibit progress. So these conversations, in my opinion, should be happening. It's important they're happening, but how we do them, I think Erin said, business has to be at the heart of it. And I think if we inhibit that growth, then we're losing another chapter. And I think for EU in particular, advanced AI and quantum is a really big economic opportunity. And for that reason, we have to ensure that regulation is aligned with, yes, protecting ethics, looking at energy, but also encouraging business and companies and startups to grow in the space.
That comes to my closing question then. What are you most optimistic about why AI will not destroy our planet?
Because it will help us to make many of our systems running more efficient, making it overall better for us. And I would come back to what I said earlier. We don't want to do this again by ourselves. We are happy to have the AI. I mean, of course, you always need it to be seen in our overall system. And I also would acknowledge there are probably boundaries, and we should also see where we put our focus and what we might not do. But overall, in particular, talking about networks, I'm pretty confident that AI will, in the end, help us and not so much cause us problems.
I think AI has the opportunity for all of us to democratize a lot of the education to places where they currently do not have enough education, they do not have enough level of education. And here, if you think about the human capital behind it, if you have a really easy access to a lot of new types of information, and people are able to empower themselves and have a cell phone and an internet connection and are able to access the same amount of information as anyone else on the planet, then all of these underutilized human capital that are existing everywhere are in a position to start solving problems. And I think if you have the low-code, no-code aspect into easy access into getting computers to help solve these problems, then all you need is the component of curiosity and human curiosity to drive all of the solutions and hopefully drive like the want for entrepreneurialism and for making something better and for creating a future that you want to hand on to other generations and all of that good stuff that panels like this always like to talk about. But I think AI, I'm kind of an optimist.
No, you think we'll work less with AI?
I think some of us have already started working way less with the complete automation of so many different things in life, and this will continue. And I think that certain people will have certain parts of their life where they work not at all or very little, and then other parts where maybe they hustle, and maybe some people will hustle more than others. I think it's the same as now, actually.
Romy?
I mean, look, on the optimist side, and given that I work in the industry, I think AI is actually helping. I mean, you can see in many use cases in industry there are benefits. But I think one thing is that AI is not an end game. AI is helping us take away a lot of the mundane, repetitive tasks that we're used to, freeing us up to actually find and solve the bigger problems that we have to face, to be able to think about new solutions for things we haven't even had the capacity to think about because maybe that part of the problem was not cleaned up or it was completely unclear. So I think that AI is actually really beneficial. And I think if we look at things like, for example, protection of biodiversity, being able to use classification better, looking at weather modeling for predicting natural disasters, these are all the kind of things which there's no brainer that these things are actually helping us. The question is always just how do we govern that? And we always have to remember this because AI in the wrong hands could be destructive, but that's up to us as societies and communities and governments to work together and ensure that we are making that progress. And apart from the cat videos, also not using AI for actually malicious activity.
Wow. I mean, the cat videos is one part. So I still have time for 2 more questions. Anyone? Any takers out there? No? Okay. Thank you. So you have been a great audience and great fun. Oh, yeah, yes, question? Come on. We'll give you the mic. No. Yeah.
My question may be a little bit more repetitive, but still, regarding the factor that what do you think would be the effect when quantum computers come in, and the combination of quantum computers and AI? How would that combination play out?
It's firstly super exciting because I think this is like a breakthrough for so many different problems that we can't solve today. For example, in drug discovery, I mean, this is an area that costs so much money every year. I don't know if one of the stats that I read was what a single drug can cost up to $9 billion just to go from actual start to actual production. If we can reduce that cycle, reduce that cost, and actually solve the problems and help people find like the actual drugs to stop the diseases, that for me is really exciting. But that can only be done with things like quantum computing because we cannot model certain sizes of molecules today. And let's think of another example about carbon capture. Like we're talking a lot about how do we reduce emissions. What about the evolution of actually capturing and re-sequestering those emissions? That's what you can do with quantum computing. You can look at big, larger molecule structures, build new metallic structures. You can think of other ways and other materials to do things. So I think there's a lot of excitement. And then the other part, like I mentioned right now, is about the evolution of these large and these large models, right? If we think about right now, it's LLMs, but if we move forward to open models for weather, NASA's already started it, DLR has been looking at it, we've been looking at it. I think these are things which are going to really open up, and I'm super excited. And then the other part is security. We haven't talked about that today, but behind all of this AI is security as well. How do we protect our information and data? And that's what quantum will give us as well, the chance to actually protect and have full autonomy of the data that we actually own, making it impossible to almost hack into that. So it's a super exciting time, and I hope it's much sooner than many predict. And in our world, we see it every day, but I think it's going to be coming to a lot more companies around Europe and application in the real world.
Just to build on top of that, all computing processes today at n, quantum computing is taking the square root of n. That's the amount of time that you can actually process, the processing speed of quantum. Any other questions? Oh wait, one more. Come. Yeah.
First, thanks for the nice insights, and I just want to bring up this question. So we're talking about a big giant computer doing a lot of things like crazy stuff, let's say, but I also imagine somehow all the individuals will have some kind of devices. I mean, it's already there. That having tiny llama or small kind of language model, and then the agents talk to each other. So you're not deciding your let's say purchase. That your agent will talk to each other. And how would you imagine this kind of world? Is it good or bad, or you think it's kind of okay, or is it something that it's better to think about better use of technology?
Well, you
That's
can
my
also
question.
add the Bumble CEO, the dating CEO, saying that you're using a couple using agents to test each other out to find whether they get the perfect match. But I'm going to leave the experts here to tell me what will happen with all these agents going across.
Well, look, in my opinion, it goes back to Aaron's point about the use case of what you're using AI for. For me, if that agent is talking to another system in an industrial process to basically pick the right process to do to make things more efficient, yeah, 100%. Let the agents talk to each other so that they can make the most accurate and fastest decision. But if it's me and Aaron and our digital twins talking to each other about which bar we're going to go to tomorrow.
Whether to swipe right on somebody, what is going to be left for the human in terms
Exactly.
of entertainment if your agent is doing the swiping?
No, absolutely. But yeah, I think so. This is that for me. That's the real question of what you see as valuable. But for me, it's always about that pragmatism there. And I think if we could focus our energy and efforts on the real bigger problems we have, I think it's a better use of investment. But that's just my view.
Anything to add?
I mean, it's a pretty, I would say, philosophical question on how to deal with all the several agents. And I think at the end of the day, we are human beings, and it's about what is authentical and what not. And I think it will be much more complicated and complex in such a world to detect whether I'm here screwed or it's authentical. And I think our human desire will keep asking, is it or not? So, and I could imagine that there are mechanisms or processes occur which will help the people to verify on this, because we want to be sure about it, yeah, with who we are dealing. And that might be things we cannot imagine yet, because today we are doing this because I have a visual on you and I immediately can process a lot of data and come to my conclusion. But if it's about the agents, it's more complicated, yeah? And I think in this new processes, in this new verification processes, and I'm not talking about what we have now in order to use your online banking and stuff like this. It will be much more complex. And I think here we will see entire new things which will change also the interaction which we have in a society.
And just like that, I want you all to give a round of applause for the panelists.
It's time to wake up.